In this exercise, we're going to simulate a spring-loaded cam and valve arrangement shown here, and we're going to find that Inventor allows us to determine the contact forces between the valve and the cam, the forces in the spring, and the torque required to turn the cam. Once we set up the appropriate relationships and run the simulation, we'll be able to view the results in the output grapher, and the final step in the process will be to output the results to a Microsoft Excel spreadsheet. The skills and techniques picked up in this exercise will be able to be used time and again in our work with the RC Racer. This is exactly the need-to-know type knowledge that will allow you to set up and analyse the shock absorbers or to understand what's going on in the pistons. So step 1 in the process then is to open the assembly file cam valve grapher analysis, and you'll find that there's 3 parts: the support here and the valve itself, which is already constrained to run in a hole at the base of the support, and the cam, which currently spins freely and is supported by means of a hole in the back of the support. So we'll start the process then by going into the Environments tab and click on Dynamic Simulation. If a dialog box comes up asking you if you want to view the tutorial, say no for now, but it's well worth watching at some point in the future. One point worth noting is that when you go into the Dynamic Simulation environment with an assembly, all of the constraints that you have are automatically turned into joints and placed in a standard joints folder. The first and most important task in this simulation then is to make sure that we take account of gravity, and we do that by going over to the browser, and in the external loads folder we find gravity. We're going to right click on it and say define gravity. The actual value for gravity is already there. What we're going to do is nominate an edge to allow us to correctly direct the gravitational pull. So I'm going to grab this back edge just here, and the direction is pointing correctly downwards. If it had been pointing in the wrong direction, I could flip with this button here, but I'm happy with the direction for gravity, so I'll say OK. If I click play at this stage on the simulation player, the valve drops away due to the effect of gravity. That reassures me that I managed to set gravity up correctly. Important to click back on construction again in the simulation player. And we're now going to go through the process of inserting a spring within the assembly, but we have to make a couple of adjustments before we do. I'm going to right click on the prismatic joint in the browser and select Properties, and click on the Degree of Freedom 1 DOF 1 tab, and in the position field just here I'm going to edit that value to 8mm, and I'll enter that value by hitting the tab key on the keyboard. And you may have noticed the valve just jump up into position there. The 8mm refers to the distance between these two faces here. I'll say OK to that. And the way that we insert the spring is to go into the Insert Joint tool, and in the drop down menu here near the bottom select Spring. We position the spring by making 2 selections in the assembly. The first selection that we're going to make is on this circular edge near the base right here, and the second selection on the circular edge on the underside of the valve just here. And we'll OK that, and the default spring is inserted. Currently that default spring is locked, so we'll unlock it by going into the Force Joints folder and right click on that spring and uncheck Suppress. And go back into the spring and right click on it again and select Properties, and enter a stiffness value of 1 and a free length of 50mm, which will apply a small preload tension on the spring. The radius value in the expanded portion of the dialog box should be set at 12, and when we OK, these values will apply to the new spring. We could now hit play in the simulation to see where we are, and there should be a small oscillation in the valve due to the preload in the spring, That's absolutely fine. Go back into the construction mode to make the last couple of amendments. This very important step is that we have to insert a joint between the end of the valve and the face of the cam. So we'll click insert joint, and the type of joint we're looking for from the drop down menu is a 2D contact. We've got two selections to make here. The first selection and the second selection, importantly, are going to be 2D geometry. It'll be very easy to pick the wrong thing here. We're looking for the 2D sketch geometry and not any faces or edges here of the 3D model. I'm just going to manoeuvre into a better position just before I make my two selections. So selection number 1, I'm going to grab the sketch geometry just here. And selection number 2 needs to be the yellow sketch geometry here. I probably should zoom in to get a better chance of grabbing the right thing, just like so. And that's my two selections. I'm comfortable with those, so I'll say OK. And having made those selections successfully, I've got a contact joints folder in the browser now. We're going to edit the properties of that joint that we just created in a second. Just before we do, we're going to use the view face tool to look square on this face. And then we'll go into the browser and expand that contact joints folder, right click on the joint and select properties. So in the 2D contact dialog box, I'm going to check the normal option and enter a scale value of 0.003 and check tangential and make sure the value is 0.01 and OK that. And just about the last step in the process is to add imposed motion on the cam to get the kind of motion that I'm looking for. So I'm going to go into the browser again and expand the standard joints folder, and on the revolution joint I'm going to right click and say properties and click on the degree of freedom 1 DOF1 tab and click on the edit imposed motion button. Make sure you've checked the enable imposed motion box. Ensure that velocity is selected, and from the drop down arrow here make sure constant value has been selected and edit the value in here to 360, and with all of these in place say OK. Just before we run the simulation, I'm going to make sure I can see the whole assembly. I'll hit run now. And that's my simulation running as I expected. I'll just go back to the start of the simulation and run that one more time. Having watched the simulation operating and confirming that it's mechanically fine, I want to produce a visual representation of the forces going on in this system here, and I can do that using the output grapher. Just click on the output grapher here. I'll bring the dialog box down, and I'm going to resize this dialog box just to clarify the next step. I'll just drag that out. That's fine. And here's how to go about bringing up the results. I'm going to expand contact joints, 2D contact, point 1, force, and then select force 1. And I'm going to do the same with force joints, spring, force, and then select force Y. One use for the grapher is if I go anywhere in the graph and double click, a black line appears and I can see the point in the cycle at which these forces apply. And then if I use the left and right cursor keys on the keyboard, I can advance right or left to various points in the cycle, and you can see that the forces are about to increase just as the cam pushes down on the valve, and that's it at its maximum right now. And then the forces start to reduce and minimise as the valve goes back up. One useful feature is the ability to export this graphical force data from the grapher to Microsoft Excel. There's a button for that right here. I'll click on it and I'll say export to single chart, OK that, and OK that, and I have a ready-made graph in Excel showing the characteristics of the forces in my system.